So my name is Gomez. This is the fourth problem of the retake exam retake of CERN 3301. Please hit pause and try to do the problem first. I'm gonna do the problem in a minute. Okay. Here it says, assume that 87.54% of houses are built from natural materials, wood, rock, etc. If you randomly select 100 houses, what is the probability that at most 98 are built from natural materials? If you randomly select 100 houses, what is the probability that at most 98 are built from natural materials? Okay, to do this, there are a few ways of thinking about this problem. And first, if you've been following problem by problem, you probably know that this is gonna be better done with the complement, right? If you use the complement, instead of calculating the probability that the number of houses is 0 plus the probability that is 1 and until 98, you say, no. I'm gonna do just the opposite. I'm gonna do the complement because it's gonna be way easier to calculate the probability that at most 98 houses are built from natural materials. So in this case will be 1 minus, and look, I do a bracket just to make sure that you understand, minus the probability that really it's 99 houses plus the probability that you find 100 houses that are made from natural materials. Okay. So again, trying to do the problem this way, it's a lot, and it's not the intended way. It will take you a long time, and you will not probably get to the right answer. So this is the first step. The first step is identifying that, yeah, of course, you're gonna use the complement because it's gonna be way easier to solve. Now, after you identify that, then you need to see how can you know the probability that 99 of these houses are built from natural materials. Now, here the issue is that you have to identify how to solve this problem. And it's fairly easy, but it's not thinking that it's just something like 0.8754 by 99 or something like that. It's fairly close. It's fairly, there are some things there, but it's not that. It's not that. Okay. So let's look. What should you do? First, you have to identify that right now there are only two types of houses: the ones that are built from natural materials and the ones that are not. Therefore, we can use the concept, or not the concept, we can use a Bernoulli random variable, or a random variable that only has two options, either success or failure. In this case, the success is that it's natural materials, okay? So that's one thing. Another thing is that from what we can gather, we might be able to assume that because these houses were randomly selected, that each house, the probability of being from natural materials is independent from the other houses. So it's not like you went to a community that all the houses are the same, so obviously the probability of having more houses of one type is higher. Here, because it's a random selection, that probability will be independent from one house to the other. Another thing that we can see here is that the probability remains constant. And because the probability of you finding a natural material house remains constant, and all the other things I have said before, we can identify that this is solved with the binomial distribution. To solve with the binomial distribution, you really have to identify three things. And if you remember, those were n, the number of random samples, in this case, that will be 100 for both cases. You need to identify p, that's the probability of success. If we are declaring success for a house to be made of natural materials, that will be p, and r, or k, or the amount of successes. And we have, in one case, that's going to be 99 cases, and in another, when we 100 will be success. Okay, so we really have like two things to calculate using the binomial distribution. So let me calculate just the first one here. The probability that is 99 houses. So that will be, and we're gonna write npx. So n is 100, p is 0.8754, and x is 99. But really the formula is this: nx px 1 minus p 1 n minus x. Okay, that's the formula. Okay, so based on that formula, if you input those numbers in the formula, I'm going to show it anyway. Based on this formula, you will have 199.8754 99 1 minus 0.8754 1. Okay, so let's calculate that, and that will be the probability that 99 are built from natural materials. It's not the final answer. Okay, so that will be something like, let me erase this, that would be something like 0.000023 okay, something like that. Now let's calculate the probability that x is 100 now. Okay, so the difference here, based on the formula, will be that this is 100, this is 100. This really will be 100 minus 100, so that this will be a 0. Okay, so really this is a 1, just in case. This is a 1. Okay, but you can calculate it completely. It's okay. You're just gonna find out. You calculate that. So let me calculate the other number. This is 0.00000166. Now I'm gonna do the math. I know where this is gonna go, and you should probably be guessing where this is gonna go now. But if I put those numbers here, 0.00020, no, 1 0 extra, 0.00237, and the 0.00000166. So let me calculate that number completely. So yeah, this is gonna be 0.9999746, or something like that. Now the thing is that if you round this up to the 4 decimal point here, this will go to one more, to 1, right? This will be a 0, 1, 0, and 0, and 0. Therefore, you will end up with a number that is approximately 1. It's a 1 just because you were rounding and you needed to round up. So that's an approximate 1. You have to remember that the 1s and the 0s are kind of sacred for us in probability. When something has a probability of 1, that means that it has to happen. When something has a probability of 0, means that it's impossible for that thing to happen. So approximately 1 is telling you that, this has a high probability of occurring, but still is not necessarily going to happen. The same happen with approximately 0. Yeah, it's highly unlikely, but it can happen. So it's very important. Remember, especially when you are rounding to 1 or to 0, to say that it's approximately 1 or approximately 0. Okay, I hope this was useful for you.